So this is chapter 4, section 6, number 7. So it's asking first, does Rolle's theorem apply? So what does Rolle's theorem say? First, it must be continuous. So I would have to say first, f of x is continuous. How do I know that? Because that's a polynomial, and polynomials, we just know it's continuous everywhere. So f of x is continuous. You could write everywhere, but continuous implies everywhere. And the derivative exists. You just know if you have a polynomial, the derivative always exists. There's no place where it doesn't exist because there's no sharp points, there's no discontinuities. So those are first two conditions for Rolle's theorem. The third condition for Rolle's theorem is at the endpoints, the y values must be the same. So let's plug in 0. And that must equal the same as we plug in 1. Well, that's 0 and that's 0. So check. 3 check marks for the 3 conditions for Rolle's theorem. So if those 3 conditions are met, Rolle's theorem says that there must be a place between 0 and 1 where the derivative equals 0. Okay? So let's take the derivative. We could do product Rolle, or we can multiply all that out and take the derivative. I'm just going to do product Rolle. So you leave the first alone. You take the derivative of the second. The second is box squared. So you bring the 2 in front. You leave box. And you multiply by the derivative of the box. Plus, you take the derivative of the first and you leave the second alone. I don't know, I think it would have been easier if I would have multiplied that out first. Oh well. At x, I'm going to distribute that. 2x minus 2. And x minus 1 squared, I'm going to square that. You get x squared minus 2x plus 1. And then I'm going to distribute that. 2x squared minus 2x plus x squared minus 2x plus 1. And I'll combine like terms. I get 3x squared minus 4x plus 1. I hope that's right. I hope. And you set that equal to 0. So that's what Rolle's theorem says, is that if you're continuous and the derivative exists and your endpoints have equal y value, there must be a place between those endpoints where the derivative is 0. If you remember the application, you have a graph that goes from 2 same values. There's got to be a place where the slope of the tangent line is 0, at least 1. And this actually, that one had 3. Whoops. The one I drew, 1, 2, 3, there were 3 places. So you're guaranteed at least 1. So to find that place, I just solve. I set my derivative equal to 0 and I solve this thing. So it's got to be 3x and x, 1 and 1. That gives me 1x. That gives me 3x. To get a negative 4, I have to have a negative and a negative. So it's got to be minus minus. And you can double check that, and that should be perfect. And to solve this equation, I set each factor equal to 0. I get x equals 1/3, x equals 1. Now, you have to check to make sure those points are between my endpoints. My endpoints are 0 and 1. This is not a point guaranteed because it guarantees a point between the endpoints. So you wouldn't actually consider 1.